Question 1. VPC security. A company is running a multi-tier web application on EC2 instances in a single VPC. The application tier instances process sensitive data and must not be directly accessible from the Internet, but they need to download daily security patches from the Internet. The operations team needs SSH access to these instances from their corporate on-premises network only. Which is the most secure and operationally efficient design? Option A. Place application instances in a private subnet. Attach an elastic IP to each instance and configure a network ACL to allow SSH only from the corporate IP range. Create a NAT gateway in a public subnet for outbound Internet access. Option B. Place application instances in a private subnet. Create a NAT gateway in a public subnet for outbound Internet access. Use AWS Systems Manager Session Manager for SSH access, eliminating the need to open port 22. Option C. Place application instances in a public subnet. Configure a security group to allow inbound SSH traffic from the corporate IP range and all outbound traffic. Use a host-based firewall on the instances to block all other inbound traffic. Option D. Place application instances in a private subnet. Create a bastion host in a public subnet. Configure the bastion's security group to allow SSH from the corporate IP range. Allow SSH from the bastion host in the application instance's security group. Create a NAT gateway for outbound Internet access. Answer 1. Explanation. Correct answer B. Option B is the most secure and efficient. It uses a private subnet to block all direct Internet inbound traffic. A NAT gateway provides secure outbound Internet access for patches without exposing the instances. Crucially, it uses AWS Systems Manager Session Manager, which provides secure, auditable, and IAM-controlled shell access without the need to manage SSH keys, open inbound port 22, or maintain a bastion host. Option A is insecure. Option C is highly insecure as the instances are in a public subnet. Question 2. Load balancer. An e-commerce platform uses an application load balancer and an auto-scaling group of EC2 instances. During a flash sale, the application becomes slow and users report errors. CloudWatch shows a spike in the HTTP code ELB5XX count metric. The backend instances appear healthy. What is the most likely cause and solution? Option A. Cause: the EC2 instances are running out of CPU. Solution: scale out the auto-scaling group by adding more instances. Option B. Cause: the ALB has reached its maximum connection capacity. Solution: request a limit increase for your ALB from AWS support. Option C. Cause: the SSL/TLS negotiation is consuming too much CPU on the instances. Solution: offload SSL termination to the ALB. Option D. Cause: the ALB's idle connection timeout is set too low. Solution: increase the idle timeout setting on the ALB. Answer 2. Explanation. Correct answer B. The HTTP code ELB5XX count metric specifically tracks errors generated by the load balancer itself, for example 503 errors, not the backend instances. A common cause of this during sudden traffic surges is the ALB hitting its soft limit for concurrent connections or new connections per second. The solution is to request a limit increase from AWS. While A and C are common performance issues, they would likely manifest as high latency or errors on the instances, not 5xx errors from the ALB. Option D would not typically cause a spike in 5xx errors. Question 3. Data analytics. A data analytics team needs to run complex queries on a 100 TB dataset stored in Amazon S3. The queries are highly variable and are run only once a week. Which service provides the most cost-effective and serverless solution? Option A. Provision an Amazon Redshift cluster and load the data into it before running the weekly queries. Option B. Use Amazon Athena to run standard SQL queries directly on the data in S3. Option C. Use Amazon EMR to create a transient Hadoop cluster each week to process the data. Option D. Use Amazon RDS for PostgreSQL with a large instance size to import and query the data. Answer 3. Explanation. Correct answer, B. Amazon Athena is a perfect fit for this scenario. It is serverless, so there is no infrastructure to manage. You pay only per query for the amount of data scanned. Since the queries are run infrequently once a week and are ad hoc, the pay-per-query model is extremely cost-effective. Redshift requires provisioning and paying for a cluster 247, which is expensive for intermittent use. EMR is powerful but has more overhead for cluster management compared to the simplicity of Athena. RDS is entirely the wrong tool. It's not designed for petabyte-scale analytics on flat files in S3. Question 4. S3 Security. Your company must ensure that all data uploaded to any new S3 bucket is encrypted with ES-256 encryption and cannot be made public. Which is the best method to enforce this company-wide? Option A. Configure default encryption on each new S3 bucket to use SSE S3 and enable the bucket policy to block all public access. Option B. Use an AWS config rule to automatically enable default encryption and block public access on all S3 buckets and remediate non-compliant resources. Option C. Create a service control policy that denies permissions to create any S3 bucket that does not have default encryption and block public access enabled. Option D. Use an IAM policy attached to all users that denies the S3 put object permission unless the server-side encryption header is set to AES-256. Answer 4. Explanation. Correct answer, B. While A is a correct manual configuration, it doesn't enforce the rule. An SCP is a powerful guardrail, but it prevents bucket creation without the settings. It does not automatically apply the settings to buckets that are created in compliance. AWS config with automatic remediation is the best practice for enforcing organizational compliance rules. It can continuously monitor and, crucially, automatically apply the required settings like default encryption and public access block to any new or existing non-compliant buckets. Option D only covers object uploads, not bucket-level settings or prevention of public access. Question 5. DynamoDB backup. A mission-critical application stores its state in a DynamoDB table. For compliance, you need to ensure a point-in-time recovery window of at least 45 days. How do you achieve this? Option A. Enable DynamoDB streams and configure a Lambda function to archive every change to an S3 bucket with Glacier Flexible Retrieval Storage class. Option B. Enable PITR on the DynamoDB table. This provides continuous backups for the last 35 days, which meets the 45-day requirement. Option C. Create an on-demand backup of the DynamoDB table every day and set a lifecycle policy to delete them after 45 days. Option D. Enable PITR on the DynamoDB table and create an on-demand backup at least once every 35 days. On-demand backups are retained until explicitly deleted. Answer 5. Explanation. Correct answer, D. PITR by itself only provides a recovery window of up to 35 days. To meet a 45-day requirement, you must supplement PITR with on-demand backups. On-demand backups are full backups that are retained indefinitely until you delete them. By creating an on-demand backup at least every 35 days, you can effectively extend your recovery capability. For example, you could restore a 40-day-old state by using a 40-day-old on-demand backup and then using PITR to roll forward the changes from the logs. Option A is complex and not a native backup solution. Option B is incorrect as PITR only covers 35 days. Option C would work but is less efficient and more expensive than the combined approach in D. Question 6. RDS recovery. A financial application uses an Amazon RDS PostgreSQL multi-AZ deployment. A developer accidentally runs a drop table command in production. What is the fastest way to recover the table with minimal data loss? Option A. Initiate a restore from the latest automated backup. This will create a new RDS instance. Option B. Promote the standby replica in the secondary AZ. The dropped table will still be missing, but you can export it from a backup and import it. Option C. Use the RDS event subscription to trigger a Lambda function that recovers the table from a read replica. Option D. Perform a point-in-time recovery to a time just before the drop table command was executed. Answer 6. Explanation. Correct answer, D. Amazon RDS automated backups combine daily full backups with transaction logs. This enables point-in-time recovery, allowing you to restore your database instance to any specific second during your retention period up to the last 5 minutes. This is the fastest and most precise method to recover from a human error like this, as it will restore the entire database state to the moment right before the accident. Option A would restore to the time of the last daily backup, losing up to 24 hours of data. Promoting the standby is for infrastructure failure, not data recovery. The standby is a mirror and the drop table command would have been replicated there instantly. Option C is not a standard or supported recovery method. Question 7. HPC storage. You are building a shared file system for a Linux-based high-performance computing workload that requires sub-millisecond latencies and throughput of hundreds of GB per second. The workload runs on a cluster of EC2 instances in a single placement group. Which storage solution should you use? Option A. Amazon EFS. Option B. Amazon FSx for Lustre. Option C. Amazon S3. Option D. Amazon FSx for Windows File Server. Answer 7. Explanation. Correct answer, B. Amazon FSx for Lustre is explicitly designed for HPC workloads. Lustre is a popular open-source parallel file system that provides the sub-millisecond latencies and massive throughput required by demanding applications like financial modeling, genomic analysis, and media rendering. It can seamlessly stage data from Amazon S3. EFS is a good network file system but does not provide the same level of performance as Lustre for parallelized workloads. S3 is an object store with higher latency, unsuitable for a file system. FSx for Windows is designed for Windows-based workloads, not Linux HPC. Question 8. VPC subnet. A VPC has CIDR 10.0.0.0.016 with public 10.0.1.024 and private 10.0.2.024 subnets in US East 1A. You need to create a new subnet for a database tier that can scale to 50,000 hosts and is highly available. What should you do? Option A. Create a new subnet with CIDR 10.0.3.019 in US East 1A. Option B. Create a new subnet with CIDR 10.0.3.019 in a different AZ, US East 1B. Option C. Create a new subnet with CIDR 10.0.3.016 in US East 1A. This will not conflict with the VPC CIDR. Option D. Create a new subnet with CIDR 10.0.0.3.022 in US East 1A and another in US East 1B. Answer 8. Explanation. Correct answer, B. The requirement is for high availability in a large number of hosts. High availability requires spanning multiple availability zones. A19 subnet provides 8,190 usable IP addresses, which meets the 50,000 host requirement. Wait, no it doesn't. This is a trick in the question. A16 provides 65,534 IPs, but you cannot create a 16 subnet inside a 16 VPC. The largest subnet you can create is a 17 providing 32,766 IPs, which is still insufficient. The VPC CIDR 10.0.0.016 is too small for this requirement. However, among the options, B is best because it addresses high availability by using a different AZ. The correct real-world answer would be to create a new VPC with a larger CIDR like 14 and then create large subnets in multiple AZs. Question 9. CloudFront Security. A content delivery application uses Amazon CloudFront. You need to prevent users from bypassing CloudFront and accessing the content directly from the origin, an S3 bucket. How do you achieve this? Option A. Configure the S3 bucket policy to allow GET-OBJECT requests only when the referrer header matches the CloudFront distribution domain. Option B. Configure an origin access control on the CloudFront distribution and update the S3 bucket policy to only allow access from that OAC. Option C. Create a CloudFront function to validate a custom header that is added to every request. Option D. Use AWS WAF attached to the CloudFront distribution to block requests not originating from your application. Answer 9. Explanation. Correct answer, B. Origin access control is the modern and recommended method to secure an S3 origin for CloudFront. It creates an IAM role that only your specific CloudFront distribution can assume. The S3 bucket policy is then updated to only allow S3 GET-OBJECT for that role. This effectively blocks all direct access to the S3 bucket. Only requests coming through CloudFront are granted permission. Using the referrer header is an older, less secure method as headers can be spoofed. Option C adds complexity but doesn't inherently secure the S3 bucket. WAF protects against web exploits but doesn't prevent direct S3 access. Question 10. SQS messaging. A company wants to decouple its application using asynchronous messaging. Order processing messages must be processed in the exact order they are received, and each message must be processed only once. Which Amazon SQS configuration meets these requirements? Option A. Use a standard SQS queue with a visibility timeout set to 5 minutes. Option B. Use a FIFO SQS queue with content-based deduplication enabled and a processing timeout longer than the visibility timeout. Option C. Use a standard SQS queue with Amazon SNS fan-out to multiple consumers for faster processing. Option D. Use a FIFO SQS queue with high throughput mode enabled and a visibility timeout shorter than the processing time. Answer 10. Explanation. Correct answer, B. The key requirements are strict ordering and exactly once processing. Only FIFO queues provide exactly once processing and guaranteed ordering. Content-based deduplication using a message deduplication ID ensures that a message with the same content is not added to the queue more than once within a 5-minute deduplication interval, preventing duplicate processing. Ensuring the processing task finishes before the visibility timeout expires is crucial to prevent the message from becoming visible again and being reprocessed. Standard queues offer at least once processing and do not guarantee order. High throughput mode for FIFO is for very high usage but has minor trade-offs on deduplication and is not related to the core requirement. Good luck. You're great. Good job. You've got this. AWS certification success is within your reach.